Hello people, Joe from Hello Sailor Effects here. Welcome to today's video. Today we're going to be taking a look at how to build a DOD250, or for my American friends, 250. In this video we're going to look at a step-by-step guide of how you can take components and tagboard, put it all together and make your very own boutique DOD250.
Did you really just refer to yourself as boutique? Joe, you absolute loser.
Stick around to the end and I'll be sharing some tips and tricks. I'll be sharing how to do it, how not to do it, and how Joe does it. Cheers! So as voted by the fine people on my Instagram, here we have the DOD250. This is a tagboard layout that was drawn by someone called Gust, and then I've cut the picture off. Apologies to the original author of this drawing. I will link this article in the description below so you can all follow it and find the drawing to follow along with this project. Okay, so first thing you're going to need is a soldering iron, solder and tools. To learn more about which tools I recommend and hear me drone on about soldering irons for 5 minutes, take a look at the Boss BD2 video that's linked below, and I go through all of that on there, so it doesn't seem right for me to cover it several times or every single time I do a beginner video. And in fact all of my videos are no doubt going to be beginner videos. So let's get into it. I've never looked at this circuit before now, so full disclosure, I've never looked at this circuit before I downloaded it to start this project. It's actually got more components than I thought it had, which is fantastic. So here's a list of all of our components and a layout. Don't worry about understanding the layout just yet. As we go through, it will become very, very clear. But what you will need is all of these components here. I'll show you my list in a second. You'll need a gain pot and a volume pot, which I have here. So gain is going to be 500k reverse audio and volume is going to be 100k audio. And you also need a tagboard. Now I will list this down below, a link to where I get them from, because it's quite a niche thing. But this isn't the only type of tagboard. You could use a eyelet board like Fender did for their original amplifiers. It doesn't have to be one of these, but the principle is the same. Right, now onto the components. As if by magic, here is my list of components with components attached. If I'm building something that I've never built before, or I'm unsure about the project that I'm doing, I like to lay it out like this. I have all of my resistors on one side, my capacitors on the other side, various other components, and a big old strip of tape down the middle with the components stuck to it over the values that they represent. It just really helps me keep my mind focused on what components I'm using. When I first started out, I messed this up so many times. I must have built 100 circuits that didn't work, and most of the time it was down to the fact that I put the wrong component in the wrong place. Now, this will help get round that massively. If you watch my Boss Blues Driver video, as previously mentioned, you will see pretty much how I choose most of these components. So it is worth going and watching at least the beginning of that video to get a feel for how my eclectic mix of components has come together. Now there are some differences, this is the caveat, there's some differences from what's on this circuit to what I'm going to use today. The main one being that I don't have a reverse audio gain pot, so I'm just going to use a 500k audio pot. We'll see how it goes, see how the sweep is, and if I don't like it, I can always change it at a future date. Secondly, I didn't have any LM741s, fair enough. But I have got a really old LM301, 301 AM. That's it. That'll do the same job. Opening up a can of worms there, because you go on the forums and there'll be descriptions of every different IC or OPAMP, and it'll tell you, this one sounds like this one sounds like that. I don't really know because I've never built the circuit before. So if in doubt, go with something that I know isn't Chinese fake and that is a bit older. Bosh or bingo, we're going to go with that. Diodes for forward voltage, although To be perfectly honest with the 4841s, 4148 is my dyslexia kicking in. Yeah, with the 4148, they all tend to test roughly the same. And here we've got the 1N4002. Now I've only got the 007s in stock, and that's what I'm going to go with. Most of the 1N family of diodes, for the guitar pedal purposes, there won't be too much difference between them. Obviously there is a difference, and when you get into the high voltage circuits, I certainly wouldn't be putting a 1N4001 as a rectifier diode in an amplifier, put it that way. But for a pedal, I think we're going to get away with it. Also, I didn't have a 100 ohm resistor again, and I just cannot. I thought I had a bag somewhere, I cannot find them. But what I do have is this really old RS Components resistor, 200 ohms, which it's a 5 watt one, so it's ridiculous size. Fits all the criteria that I like: overvalue, ridiculous size, and unnecessary, and old. So I'm going to use that. It is on the input, so I don't think it's going to make too much difference. Now I'm sure there's lots of DOD250 aficionados screaming at the screen now and telling me I'm building the worst pedal ever. This is what I'm going to do, and I'm sticking with it. Right, next, what I'm going to do is I'm going to take my circuit and I'm just going to start populating it from the left to the right. No other reason than that's the way that I read. So I'm going to go in that direction, and I advise everyone to just, some people do resistors first and then move on to capacitors. Some people will put all the components in and then solder it. I like to just go one at a time and solder once each lug is full of all the components that it's going to have. Let's go. Just before we move on, I thought I may mention actually my enclosure. So I know in my audio probe, and I'm sure you've all watched the Give Your Pedal a Good Probing video. In that video I explain that I'm going to try and prep better for my videos, and quick as a flash I didn't prep better, so I didn't have an enclosure ready for this pedal in time. And I thought, this is a beginner video, so I'm going to go full on beginner with the enclosure. I've stuck a bit of enamel artwork to the front of it and my branding on a sticker. I've left the enclosure bare aluminium, and I think I'm going to leave it like that. But either way, I've gone beginner with the enclosure, and this is the one that I'm going to use to house the pedal. And actually, when I sell this pedal, it will be in this enclosure. When we first start, I want you to ignore this board here. We'll get to that later on. And I also want you to ignore all the wires coming off the outside of these circuits, and also any component that's mounted. What am I talking about? Mounted. English, Joe, you speak the language. Mounted in between the lugs. I'm going to forget about them until later on. I'm just going to focus on the center line first. And as you can see, the first capacitor, oddly enough, is C1, which is a 10NF capacitor. For me, I have this Ukrainian-made Soviet era paper and oil capacitor, military spec. This is going to be my first capacitor. Of course, I'm going to use my scalpel because I'm never normal using anything that normal people would use to clean leads. I'm going to use my scalpel, clean the leads, and then I'm going to manipulate the legs until they fit through the lugs. And looking at this drawing, once I've got this capacitor mounted, I'm going to solder this end, but I won't solder this end until I put R2 in place. Then I'll solder this connection here. I think this will become apparent as we go through the build. And there we have the first component installed. Now my capacitor was too big to fit through the gap between the lugs in our tagboard. To get around that issue, all I've done is created a skyhook shape in the leg to apologies team, I'm so used to teaching sailors that I slip in and out of my naval terminology. A skyhook is actually a metal shaped hook that you use when the ship has took battle damage and was sinking or what have you. Use it to hang off strong points on the superstructure, on the ship's body if you like, to hang your gear off or hang cables in to keep them out of the water. and whatnot, and it's kind of that sort of shape. So this isn't battle damage and this isn't a warship, but that is kind of the Skyhook shape, if you can see there. And that's what you make both ends, and that means that you can use ridiculously massive components on your circuit board to be cool, just like me, or a geek, whichever way you want to look at it. So what we have here is C1 is attached. I slipped that component in place. I wetted my tip. I tell you what, everyone found that hilarious in the last video, and I thought it was kind of an industry standard term, but it turns out it's not. It's just a Joe standard term, and I've been saying it for years, and it's not a thing. But anyway, I wetted my tip and I soldered just this end over here, C1, on the input side. Then I placed R2 in place and soldered C1 and R2 together at that terminal here, and that's where I am now. Next, I'll be placing in R3. I'll solder this end, but I will not solder this end here, because I've got to place C7 and R8 in place before I can do that. Once C7's in, I'll be able to solder this earth connection end, but I will not be able to solder this one, because again we go into another triple component, and I'll just work my way through the board until I get to the end of it. So now we're up to C7, which is an electrolytic capacitor like this. I've chose to go axial for this type, although for C6 here I've actually got a different style of capacitor, like a can cap, whatever. So what you need to think about is, on our drawing, this little line here, this minus sign, is the negative side of the capacitor. Now if I can get that in view there, on the top of here we'll have arrows pointing to the negative side of the capacitor. Also the positive side, which is the opposite side over here, the positive side has a little indent in the positive side of the capacitor, so you can identify it. These capacitors are polar, so if you used to put it in the circuit the wrong way round, it will not sound right, and if it's doing some sort of power function, then it will fail eventually. It'll turn your nice pedal into a very expensive smoke machine. So because the arrows are pointing to this terminal here, I'm going to situate this capacitor that way round on my board, ensuring that the indent is on the positive side, which is this side, and the arrows are pointing down to the negative side, which is this side. I'll be willing to bet that one of you years, like myself, messed that up. Now here I'm on to C6, which, as I previously said, I'm not going with an axial cap this time. I couldn't get my words out before, but this is a vertical capacitor. Can see that right? So it's basically, instead of lying on its side, it's standing up. Now with these, we still have the arrows pointing to our negative side, but also the positive leg is slightly longer than the negative. That'll help you situate it the correct way round. So I have run into a little bit of a problem with R7, which, as we can see, is our 100 ohm capacitor that I'm using a 200 ohm capacitor for. Now because I went with a massive capacitor, it literally would not fit, so I had to tack it on in between the solder lugs here, which won't matter because there's no other components going in here, and let's face it, the large vintage resistor adds to the mojo, right? While we're here also, we're now on to R4, which is a 4.7k, and I'm going to use this resistor, diodes. So we're going to be wiring in D1 and D2 at the minute, which are both the 1N4148, if I'm not mistaken. These are probably the cheapest diodes that you can get. All of the forum posts that I read today say that these are the best sounding ones, so I'm going to go with it. I almost forgot to say, don't forget that diodes have to be placed in the way that they are shown on the circuit drawing, i.e. they are polar. So we need the line on this diode pointing up this direction, and a line on this diode pointing down this direction. Again, I've said before, if you want to see a comprehensive description of how diodes work, how to test them, and why to choose which diodes, please go to my beginner's tube screamer modification video, which is linked below. And I go through sine waves and all sorts of geeky stuff to do with diodes in that video. Now that we have our center line of our circuit board or tag board wired up, next we're going to move on to these pesky components on the outside. Now to connect these, all I'm going to do is, instead of threading them through the lugs that the aisles that we have been using thus far, like it shows on these drawings, I'm just going to put them all going through the holes in the center of the tag board. I'm going to start at this end with R1 and I'm going to work my way to the right. Now one thing I should have mentioned that I didn't is that when mounting these components going to the side of the tag board, I keep wanting to call it a circuit board. It's not a circuit board, it's a tag board. These components on the outside edge of the tag board, normally people will lay them flat against the tag board and then solder them in. I like to leave them raised a little bit, just like that. Mainly because if you have any sensitive components, bearing in mind resistors aren't particularly sensitive to heat, but if you have sensitive components, a lot of heat goes into these lugs to heat them up to allow the solder to flow after you've wet your tip. Yeah, I'm never going to let that joke go now. Yeah, so I like to raise them up off the board just so then they're away from the heat. No other reason. And there's probably professional electronic engineers screaming at the screen now, or unfollowed or what have you, saying this is pointless, but this is just how I like to do it. I'm now up to capacitor C3, which is our 25pf capacitor. Now I don't have a 25pf capacitor. Seems to be a running theme here with these videos of me not having the right value, but I have got 47pf, and there's a way of halving the capacitance of each of these by wiring them in series together. If you wire two capacitors in series, you get half the capacitance, but double the voltage handling. So, here's my props to Black Beauty capacitors. If I wire them in series like this, I will drop half, providing they're the same value, that is. If these are both 47pf, for example, and I wire them like so, I'm going to get 23.5pf. So, if I was to wire them in parallel, so next to each other, both going to the same lug either side, that would double the capacitance, just like adding them together. And this way, is subtracting them. I tell you what, when I did my degree, my engineering degree, electronic maths was the most boring thing I've ever done in my life. And I'm interested in electronics. I'm interested in capacitors, you know, electron flow and all of this jazz. But you start adding letters and equations in, and I was just, my word, I was probably one of the low points of my life. I don't know if any of you people watching this have done an engineering degree or a maths degree or whatever, but I sat down in the very first class, the very first lecture, and within about 10 minutes I'd exceeded everything that I knew about maths or engineering literally in my life, and I was like, oh my word, I'm in trouble. Anyway, I did manage to get through it, and I think my degree is currently stuck to my mum's fridge. Right, so what I'm going to do, stop going on a tangent and talking about math, whatever you guys call it across the pond. I'm going to take my two 47pf capacitors. I'm going to make sure that they're orientated in the same direction, i.e. the little red tabs on them are both pointing in the same way. I'm going to put them together, and I'm just going to twist two of the legs together like so. Then I shall wet my tip. Oh, I just can't. Then I'll solder this end here, clip it short so they're near connected, and this will become one capacitor at, it would be 23.5pf if these were exactly 47pf, but I've been through and tested all my capacitors and made sure that the pair that I choose are going to give me 50pf. Right, let's get them installed. Here's another one of Joe's top tips. So as you can see on our tagboard drawing, down here we have a little link between these two terminals here. What I like to do is I save all of the snippings from my resistors, capacitors, anything with a good healthy thick leg on it.
Wait a minute! Who are you.
I'll save the ends of them, and they're perfect for just this sort of thing. And I'll just make that sort of shape with them, straight through the lugs and solder, and away you go. So now our tag board is fully wired. Maybe a little bit messy because I haven't done this circuit before. I usually start off by messy-ish layouts, and then I refine them over the years, but it's not too bad. It's not too bad. Next, we're going to move on to this board here. I leave all of these wires until later on. So straight to this board here, and as we can see, it's 4 rows high and 6 holes long of strip board or Vero board, whichever way you want to look at it. And that is this stuff. There's one that I cut to size earlier. And all that is copper strips on the back that run right the way across the board. Have I got a larger piece? Yep. So there's the board. Copper strips that run along it and make the circuit. Now, we've only got a little bit of it for this because we're making just literally the IC. It's just the connections for that. If you look underneath the IC on the drawing, there's these white and red squares. What they mean is cuts in the copper. I've seen people do various things to cut the copper. You know, there's this correct tool that looks a bit like a handheld drill piece. All sorts of stuff. A hacksaw, whatever. What I like to do is just take a Stanley blade, take the boy out of Liverpool. Can't take the Liverpool out of the boy, eh? If no one gets that joke, please go and watch Football Factory, where the main character gets stranded in Liverpool. And at that time, when that film was set, I'm going on a tangent here, bear with me. In Liverpool, it was a big thing to carry a like a carpet knife with you, I think. I don't know if that's what you call them in America. Anyway, we call them Stanley knives.
Yeah, you flash cockney bastards, you know Stanley?
And now, people from Liverpool, known as Scousers, kind of get lumped in with that sort of stereotype. I do really like using these to build with though, so think of that what you will. So we can see that we're 2 lugs across from the right, and the third lug across, 1, 2, 3, is going to be a row of split terminals. And all I do is I just place the Stanley knife inside the hole, go in a big circle, cutting out the copper, like so. And I do that for each one of them red squares until we have a cut right the way across. I hope that makes sense. Now that that's complete and we've got our row of splits down the centre of our strip board, I'm going to go ahead and fit this socket for the IC. You can solder the ICs directly to it, but if you want to change components and see what other ICs sound like, I mean, if it's not hard clipping, I very much doubt that you would hear a difference. So something like a tube screamer, you probably wouldn't hear the difference in the IC unless you've got it cranked with lots of volume and all sorts of other stuff. Anyway, I advise using one of them. If nothing else, you're not heating the IC up because these are particularly sensitive to heat. So we can place that in. Now, one thing to note when you're orientating this IC is that there's a faint semicircle cut out on the drawing at the top of this one. Now, what that means is on our IC there'll be a circle on the top of the IC, and that's saying that that is the way that it's orientated, with the circle at the top. Now, your socket should also have a little cutout on it, and I just find it's easier if you place that cutout at the top for no other reason than it will help you remember that it's at the top. And now I've put it in, I can see that I've cut a square with 5 rows in instead of 4. There's my dyslexia kicking in again. I tend to do this sort of thing all the time. Like if I'm counting numbers, oh my god, I will literally swap the last 2 digits round on any phone number or any number every single time without thinking. It's absolutely insane. Anyway, moving on. Now we have our IC socket installed onto the Vero board, strip board, whatever you want to call it. Next, I'm going to add in the cables off of this, mainly because once you install this into your enclosure, it's going to be really awkward to try and get the cables in there. So I like to do these ones first, and then I install all the others once we are inside the enclosure. One tip for this is, it's handy to know where you're going to have your components situated within your enclosure, so then you know how much wire or cable you need to cut off to make its destination. There's nothing worse than getting to the point where you're about to wet the tip to solder the connections in and you realize that your cable isn't long enough. Story of my life. Moving on, another top tip from Joe. Not sure if I've talked about this one in the past, but when I'm installing a cable to a terminal of some kind, I like to tin it first, especially if you're using stranded stuff. So for me, I'll take the insulation off and give it a twist, and you end up with something looking like this. Then I like to give it a bit of solder, wet your tip, and give it a bit of solder down the connection. Does two things really. Helps keep all the strands together when you're threading it. Ooh, I'm knocking my camera with my cap. Well done, Joe. Great cinematography. Anyway, great bit of recording. It helps stop the strands from splaying out while you're trying to thread it through one of the holes on your board. And it also helps when you come to solder it. This solder will flow with the new solder, and it just makes it all real easy to do. And it's nice and stiff, so you can bend it into shape to fit it through whatever you need it to go through. Right, moving on. Now we've got our cables attached to our IC board. I highly advise you taking your Stanley blade, knife, whatever you want to use, and just running it in between the tracks. I mean, this is only a real small board, and I can see that there's nothing touching anything that it should. Great bit of English, that. Nothing touching anything it shouldn't be. There isn't anything in contact with with anything else that shouldn't be in contact with. However, I'm still going to run the blade between the tracks just to double down, make sure, whatever, because there's nothing worse than fitting this. It's almost as bad as having a cable that's a little bit too short. You fit it all in, solder it up, there's a short somewhere, and you're chasing your tail trying to find where your issue is. So for the sake of just doing that, you might as well get it done. Next on the cards, we're going to mount all of our mechanical components, our pots, our switch, our jacks, into our enclosure. Now we've got all of our hardware installed into our enclosure, I'm going to go ahead and install our circuit boards. Now how I like to do this is a bit different from everyone else. I like to use these double-sided foam sellotape sticky pads, and I use them to elevate the tagboard away from the metal on the enclosure, so then it doesn't short out. But I like to stick it in place with this stuff, JB Weld. This is an epoxy, a steel reinforced epoxy. Now I laugh about this stuff because you American people over the pond, I believe this is quite common over your side of the pond, JB Weld. But for us English, I hadn't seen too much of this stuff before I was deployed to the South China Sea. Now, we had our stand down mid-deployment 4 months in a place called Guam. I don't know if anyone's heard of it. I certainly had never heard of it. But we were in Guam, and while we were doing maintenance on the ship, we tried to fix just about everything with this stuff. And if my old boss is watching, Aid, hello.
This is Aid. Can you spot hello sailor? Add all guesses to the comments.
I don't think he will be watching these videos. Anyway, he'll be laughing his head off right now because we tried to fix everything with this and nothing ever worked. It literally broke down every single time we used it. Now, that's because it wasn't made for military applications. Now, it wasn't made to be twisted, turned, pulled, bent on board a warship. The ship flexes as you go through the sea, as it hard turns. It's not like a cruise liner that goes in a straight line. This thing gets ragged around, and this stuff just wasn't up to the task. And so it became a running joke of that deployment, and it was quite a fun time of my life. So I use this all the time on pedals now, just to reminisce back of them days when we were laughing, saying, we'll fix it with JB Weld. Our tag board is in place, and our secondary board, Vero board, strip board, whatever is in place. Next it's going to be wiring up all of the terminals that are here. I like to start with the ones that you've already got wire on, because that tidies it up and kind of gets them out the way before you start on anything else. What I will say is, when I first started out, my wiring was absolutely shocking. The directions in which I run cabling were basically random. Now I like to keep things in reasonably straight lines, not so much, I mean certainly not like a high watt build or some sort of leak stereo, but definitely much neater. And then when we come to tidy the cabling up at the end, it will be much easier to do. So I'm going to start off now. Because I've made things awkward for myself, I've mounted this board sideways. So as I'm looking at it, number 7 is going to be the first one to be wired, which is here. And I can see that that is 4 lugs along. 1, 2, 3, 4. So it's going to attach into the bottom of C6, which is down here. And I'm just going to run that along. I'm going to tin it and then insert it and solder it on. I'll do all of these first, and then I'll leave the earth till last, and we'll have a little discussion about that once we get there. Now we have all of these wires soldered in and good to go. I'm going to move on to the earth. So this little symbol here with the three lines, that's an earth symbol. So all of these need to be joined together and then joined to our earth lug on our power jack. It's advisable to join all of these earth lugs together underneath the board before you start. And usually I would do it that way. However, I've made so many mistakes where I've just missed the lug by 1, and the pedal doesn't work, and it takes me a while to figure out where I've gone wrong. I thought maybe for a beginner circuit or a beginner attempt with Tagboard, it would be best if we just wired the earths as we see them on the top. Not forgetting that there's also going to be an earth for our LED on our 3-pole double throw switch, foot switch. If you're interested in how to wire the foot switch and the ins and outs of a basic pedal, I'll link my video down below that I take. Basically, the video is just about how you wire up the input and output of a 3-pole double throw. Spit it out, Joe. 3-pole double throw switch, and also the LED connections thereof. So if that's something you'd be interested in, please go down below and have a watch of that first, because I'm just going to smash through this now. Okay, so when we're wiring up all of these earth connections, I've pretty much wired them all up now apart from the volume pot. When you get to the jacks, even though they're earth to the enclosure, I still like to earth them to each other and then attach that to actual ground on the socket itself anyway, just for an added thing, because if one of these jacks comes loose and you're relying on that as an earth, it will just fail or create noise or whatnot. And I join them together with, and you've guessed it already, one of the component legs that have come off our components so far. So waste not, want not, channel your inner Leo Fender and use every last little bit that you can. Now all of our earths are all wired in, and the earths on the jack are all wired in. I'm going to go ahead now and just terminate all of the extended wires coming out of the board. So we've got our input wire going to a gain, and then our output and a 9-volt DC. So that's the board fully wired up. All I've got to do now is wire up the output from our volume pot and the input and output jacks, 9-volt, and of course our LED over here. I'm going to crack on with that now. That's us fully wired up and ready to go. Apart from I'm going to add in a filter section for the 9-volt power supply. Now I've kind of developed different filters for different power supplies on my pedals, but specifically for this one I'm going to use a filter power supply that came out of an old Fox wire. It was a Crybaby wire from many years ago. It's very simple. It's just a simple RC filter, resistor, capacitor. And how it's going to work is, I don't know if I've took people through this in previous videos, but we'll go through it now. So we've got our power supply in. This is where the old Joe Age 5 comes out, and this is our positive going to our circuit. It's going to go through a resistor. There's the R part of the network. And then it's going to join our circuit. Now, usually the resistor's 1K, but I'm going to use 300 ohms on this one just because I'm unsure about how much voltage this circuit requires to operate properly. I haven't looked at it properly. So we're going to go to 300 ohms. And what this is going to do is this is going to take away any of the big noise, sort of like, so how do I explain this? The 9-volt supply, although it is DC, which is a straight line, if you were to look at that really closely, it's actually more like this, whereas this would be your AC, but there's still movement in the signal, and that translates to noise. So what we want to do is flatten it out. This will take away some of the noise, but to get rid of the rest of it, the large peaks is taken away by a large value capacitor, and by large value we're talking 47 UF to maybe 100 UF. So we've got one capacitor coming out and going to earth, and that's going to say be 47 UF. And then to get rid of any higher pitched frequency noise coming through the power supply, we're also going to add in a smaller value, usually about 100 NF, or sometimes I put 22 NF, depending on the circuit, depends on how much you need. Less is always more, if that makes sense, whatever you can get away with. So on this one here, I'm going to use 22 NF. Right, and what I'm going to do, enough of the Joe Age 5. So to actually implement this, let's zoom in here. Coming from the 9-volt terminal, I've got this 400 ohm, 300 ohm resistor. I can't remember exactly which one it is. That looks like a 400. Going into our 9-volt input here. I'm also going to run 2 capacitors from here over either to an earth terminal here, or I'm going to run them up to this earth here, and it's going to be 147 UF to take out big noise, and 122 NF to take out little noise. I do this for most pedals, most of my pedals, depending on the circuit, depends on the type of RC network I use, and sometimes I'll use an inductor as well, but we don't need that for this one. So let's get implementing it. And now our 9-volt filter RC network is connected up and placed in.
This RC circuit was removed during fault finding. As you will hear in the demo, the pedal sounded absolutely horrific. Turns out the TL072 OPAMP performs much better than the original first used.
At this point, it's almost time to test. 2 things left to go. First thing I forget every single time, and I'm sure many of you will too, is to actually put the IC into the socket. The amount of times that I've come to test pedals, I've pressed play on my signal generator or started playing guitar and nothing happens, it's because I forgot to put the IC into the holder, or I've put it the wrong way around, which inevitably happens when I'm rushing to finish a project. And then also I'm going to just tie some cable ties in strategic points around the cables, even though in this build here they're quite tightly packed, so they're not really going anywhere, so it's not necessary, but I am going to do it anyway. And then we'll get it plugged in and get it tested. And now for everyone's favourite part, which knobs will I choose? So we have a choice of bakelite, standard no silver, bakelite with silver, a smaller bakelite with silver, and then some small chicken head. So let's start with the larger ones, see what they look like on there. I do feel like these may be a little bit too big for it. What do we think there? If anyone has a preference, a strong preference to which ones look the best on here, please put it in the comments so I know which ones to fit for when I put it up for sale. I mean, I really like these knobs, but I'm not sure that they fit in with this aesthetic. I feel like both of them were too big for my liking on this size enclosure, but what do you think? And then I really like this type, They are bakelite as well. They've got a little pointer on so you can see where you set. And then the all-time classic chicken head. These are the miniature versions. Is this one gonna go on? No. Yep, so these are the classic chicken head style. I kind of like them, but I'm not sure it fits in with the DOD250 theme. I don't know. Please write in the comments which ones you prefer out of them, and stand by for the audio test and you'll see which ones I went with in the end. Well, hopefully we all heard some nice sounds coming from this pedal in that audio sample. I haven't listened to it back yet, but it did sound good while I was recording it. This is the first time I've ever made a DOD250, and indeed the first time I've ever played one, I'm ashamed to say. I'd love to know what you guys think of the sound sample on that using the TLO71, and as you could probably hear, it was definitely the IC, or the OPAMP I should say, that was causing me the issues from before. So I'm going to leave this one in here, and yeah, this is going to go up for sale. It may already be up for sale by the time that this video gets posted. Let me know if you want me to build more of these, if people are interested in them. I mean, they're not as simple to build as some of my other designs, and I'm not as familiar with it, but it's certainly a nice circuit, and I think maybe I could improve on the layout and stuff in the future. Well, let me know. Cheers.